Jai Hind everyone. Myself Dr. Inderjeet Kaur, Professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In this lecture, we will be discussing about the software tools that are being used in human-computer interface. The content for this lecture will be software tools, discussion of software tools, what are their specification methods, various interface building tools, and then the evaluation and critique tools. So, starting about the overview for the user interface software tools. As we know that the user interface software, it is difficult to create, but persons, they have been working for a long time to create the tools, to get the help from them. Now, many of these tools and ideas, they have been progressed from the research point of view, and they have been brought in into the commercial systems, and their effectiveness has also been demonstrated. Now, these research systems, they will continue to evolve quickly, and the different models that are very popular 5 years ago, they have been made now obsolete, and as per our new requirement, new models, they are being emerging. Then the different components of user interface software that are being shown in this figure, as we can see that user interface software, it is being divided into various layers, that is the windowing system, the toolkit, and the higher level tools. So, these many practical systems, they have many different layers. Here is the operating system, here we have the windowing system, then we have the toolkit, higher level tools, and then here we are using the different applications for different views. Software tools, UI should be reliable. Everybody wants the user interface should be reliable, it should be standard, it should be safe, it should be inexpensive, it should be effective, its output should not change, it should be widely acceptable, and it is to be built on a predictable schedule. Now, these software tools, they help us to achieve this. The requirement, the need for using software tools is that they should be giving us the standard results, they should be very reliable. Then, what is the UI architect requirement for making this software tools? So, simple and quick methods for sketching the UIs means they want to use the precise methods for working out the details with the client, for coordinating with the team members, and then telling the developers what to do, so that the final output can be achieved. Then we use three set of tools that are widely available. One is the UI specification methods, then is the software tools to support the design and software engineering, and then to evaluate and to critique tools. First is we want to know the requirements. So, specification, standard specification methods should be there. So, first kind of tools are that. Then second, our second, it goes to design, and then tell us the concept of software engineering, test them. Then to some tools should also be there to evaluate and to critique the tools. The different trends are desktops, they are now less in use. Then we are continuously increasing the use of web, mobile, universal usability and customization. Everybody wants now these things. Then according to the increasing use of this web and mobile nowadays, there are various UI building tools, they need to be adapted for these changes. Our tools should be to accommodate, to be properly working on this mobiles, to properly working on web. Then we need to define the grammars for defining the specification methods. Means we should test if a string, it adheres to a specified set of rules. We take the example, means specification of textual commands or expressions that a program should understand. Then verification of validity of user input. For example, it is taken in the form of forms. Then examples of such grammars, they are BNF, and the problem is they are incomplete. They need supplement through ad hoc techniques to specify the semantics. So in this way we define the grammars first so that we can standardize the specification methods. So if we take the example of a grammar for UI purpose, that is multi-party grammar, that is used as the extension of BNF that labels non-terminals with a party of an interaction that produces the string. The advantage for using this is it is a formal method and it can be verified by the computer programs in order to see whether this is a complete and giving the correct result. Then the disadvantage for using this kind of grammar is it is very difficult to follow and it is a kind of a complicated thing and it is very less suitable for two ways of interaction styles. Suppose both sender and receivers, they want to interact and they want to give their inputs, then in this case it is very difficult to interact from both parties. Then BNF, it stands for Backus nor form. Here we define the non-terminals. Then suppose a telephone number we need to define. So it is a combination of area code, then exchange, and then we define the local number. Then we break the area code again. It is a combination of digits. So here the basic entity is digit again. Then we break the exchange again. It is a kind of combination of 3 digits because it is being broken. Then again the local number, it is a combination of 4 digits. So in this way the combination of area code becoming 3 digits, then next 3 digits that are occupied by the exchange, and then 4 digits they are being occupied by the local numbers where digit can vary from 0 to 9. So in this way we have taken the example of telephone number and it defined, we have written its BNF form. So I can say how it is incomplete. So it is good to specify the format, but we are failing sometimes to specify the content ki whether it is a valid exchange code or whether it is a valid area code, because we have simply written ki digit, it is a combination of area code, exchange and local number, and again they are being broken into digits. So whether it is a valid exchange, whether it is a valid area code, nobody knows. So that's the drawback for that. So for that we are saying it is incomplete. Then a second level of software that is being used to validate the content. Here comes the use of software tools that will say ki it is a digit, it is a valid content of digit or no. Means some area code that we have suppose written 0, 1, 2, whether it is a valid code for any state or no. Then again the second thing, the complex. As a BNF grammar grows, so it becomes very complex and difficult to follow or change them. So for shorter things it is very okay, and but when the network grows or when we are using a large grammar, then that's the drawback. Then the different various other variant of grammars are, suppose I have written the make, then Java C, Java compile here, then Java home here. Suppose I am using JSDK 1.3, then make I have written like F theme core make file it will call, then again chat here I am defining, and then for swab I am defining. Then multi-party grammars. These multi-party grammars, they are being used for showing the interaction between more than one party, and it was being started by Schitterman in 1982. Here in this, the non-terminals, they are being labeled by the party that generates it. For example, here we are using U for the user and C for computer. Then effective, they are very effective for text oriented commands, sequences that have repeated exchanges. For example, here we are defining the session. So, session means here user is opening and then computer is responding, fine. And then user is opening means it is through login and user is entering the name. Then when user is entering the name, what does it mean? User is entering the string. Then how does, now is the turn for computer. So here the computer starts responding and tells us, hello, what was the username. So in this way we can see it is an example of multi-party grammar because both users, they are interacting. The user is giving its input and according to that input the system is responding. Then the specification methods. Here the menu selection and dialog box trees. That is, it shows the stakeholders of a project a complete and detailed coverage of the system. Then it shows the high level relationship and low level details. It helps in discovering inconsistencies and it checks for completeness, it checks for redundancy, it checks for the ambiguity of the data. And now then, due to the intention of avoiding clutter, such trees, they are incomplete and they are restricted to a static view and they do not show the entire structure of possible user actions. Now we define a problem. See, in some aspects of user interface UI design, a precise specification of every possible action it is required. Or I can say, in case of non-menu systems, there is a need to express the set of possible states and they want some transitions. So in that case, the solution for this problem is we need to use the transition diagrams so as to know the output of every given input by UI. Then moving on to the transition diagrams. We can see a typical transition diagram, it consists of a set of nodes, means whatever the system states are being defined, they are being linked between, they are being linked together to show the transitions and every transitions they are being labeled. Then many specialized transition diagrams, they are available with specific notations for specific application domains. For example, word processing, e-commerce, for every application to application, this transition diagram can be drawn. The advantage for drawing this transition diagram, it is very effective for the following flow or action or keeping track of the current state and the options of UI. And it can be verified to have to show the reachability and to show the dead ends for every transition. Then the drawback for using the TD, they are very complex when we have multiple stages, when we have a big network. So if our system is growing, then they are very complex to draw, and our system complexity also increases because now we are having multiple states and every state will be having multiple transitions. So it will be confusing when mainly nodes they need a link to help, back, quit, etc. in their basic form, and they will show us the poor representation of concurrency and synchronization. The alternate for this transition diagram is to draw the state chart. Now what is this state chart? State chart, it is a grouping feature, means nesting of same group of the different nodes together that allows for factoring repeated transitions out. So this, it offers extensions for concurrency, it offers synchronization, and it allows external interrupt events and various user actions. Then this state chart, it offers extensions with data flow and constraint specifications. Then this state chart, it can be extended with embedded screen prints to show the visual state of graphical widget. And then the basic point for using this state chart is to draw the UML state chart diagram. Then we will discuss about the benefits of high-level software tools in the context of HCI. So first we will be talking about the user interface independence. It allows to have the separate interface design from internals. It enables the multiple user interface strategies and multiple platform support, and it established the role of UI architect. It enforced the standards, the methodology and notations that are being used in this high level software. They are we require to develop the design procedure. We look to find the ways to talk about the design, and we create the project management. Then moving on to the rapid prototyping, it means we try new ideas very early. We test it, we revise it, we test it, we revise it, and so on. This rapid prototyping means we are engaging the end users to check them for smaller set of input and then customize them according to their new requirements. So we are engaging the end users, managers, and customers. Then fourth point comes the software support. Software support means we want to increase our productivity. Then we offer constraints and consistency checks. We are facilitating in a team, and then we think about the maintenance. Then moving on to the interface mockup tools. The main purpose for using this mockup tools is to create a quick sketch. When the customer wants a quick design, so in that case we require a quick sketch for our early design, so that we can think what can be the advantages and what can be the drawback and what can be the multiple alternatives. So it facilitates the communication between designer and customer. So it is very important in case of pre-contract phase. The examples for using this interface mockup tools are slideshows, Macromedia Director, Flash Dreamweaver, MS Visio, JBuilder, VB. So depending upon the tool, either we show using the simple slides of the screens, or we give the complete demonstration for the complete prototype where user can select, navigate, click, scroll, means user can have an idea of their designed software. So prototypes, they are naturally limited. We will be showing with the limited design features. Okay, this product will look like this. Certain features are being demonstrated, and other will be whenever it will be in the complete form of design. Then software engineering tools. The main purpose, it is to build the final product. So in the earlier days, general purpose programming language that we were using were Java, C++. They were used to build the UIs from the scratch, and now it is being supported through software tools, various APIs being called, various frameworks they are being used to design the software engineering tools. Then a classification of UI building tools. First layer, we are talking about the windowing toolkit. In the second layer, we are talking about the GUI toolkit. At the third layer, we are talking about the various applications, framework or specified languages that we will be using. And at the fourth layer, top level, we are talking about the various applications that will be used by the user. What is the general trend? General trend is the lack of modifiability, means the customer wants some customization, and at the last moment they are not being modified, because the requirements should be clear in the early stages. So lack of modifiability, it led to building architectures that separate the UI from the application logic and also supports the cross-platform dependent. Then we have the windowing system layer. Here no widgets they are being available, they need to draw it manually. So no event support is encapsulated in the form of objects. So low level work is required, especially they are being useful or important for new platforms or if resources they are expensive. Then they build the basics for higher level layers. The advantage for using the Windows system layers are, first is they increase the system performance and they are very flexible. Then the drawbacks are they are very they require extensive programming and they require long learning time, and they offers little support for interactive tools, and they don't have no visualization tools. Then we have the GUI toolkit layer. This toolkit layer, it gives us the software libraries and widgets. Means they are giving us the various dialog boxes, they are giving us various scroll bars, frames, so as to handle the various events, so that the various events they can be shown by in different frames. The advantages for using them, they give us the abstraction, they have the shorter development times, they have the great flexibility, and they are based on general purpose languages. The drawbacks, they are they have the higher learning times, they have the building and maintenance time is also high, and they do not support any consistency, and the programmer that is being required, that should be experienced one. The examples for these toolkits, they are iLog views, GTK, Qt, Java, AWT and .NET toolkit. Then we have the application framework and specialized language layer. Here we are talking about the application framework, means software architecture specifically designed for building these GUIs. The main idea that came, it was many user interactive based programs, they have the similar structure and they capture the structure, they translate them into the classes, then to objects and to methods, so that they can be reused further. So the different they are being the entire structure, it is being divided into different components, and these components they are being reused. The commonly uses widgets from GUI toolkit layer are, they are to give the user convenience, to give the visual programming, they are using basically the scripting language. Then they give us the less support for non-graphical part of the application. The examples for using this application framework, they are Cocoa, MFC and Macromedia Director. Then there are some certain specialized languages, means the languages specifically designed for building UIs, and they can also be used for rapid prototyping. The examples are JavaScript in combination with HTML. Then moving on to the application layer, means interface generators, they are also called as model based system or UI management systems. So the visual tools that allows for most part of an application to be used as a one tool, or we can use it without coding. Only available for a small class of applications, means DB as a front end or to research prototypes. Then now we have discussed so many, which is the right tool to select. We have the higher level tools, they are more efficient, however there are some restrictions also. So finding the right tool is more important. Some criteria are there. We should judge and we should select based on those criteria. Means which part of the application we need to build using the tool, it entirely depends. Then how long can learning time be? Is it very short or is it very long, or are experts available to us? That is the again most important point. Then how long can be the building time? That should also be decided in advance. Then do you accept a methodology being imposed or rather advised? So if it is not being accepted, then we should not give the choice also. Then is communication with other subsystems is required? If in case yes, then multi-party communication is required, otherwise no requirement. So, do you need to consider extensibility or modularity? So, these are the important factors that should be considered while making the interface building tools. Then moving on to the build time tools, means now we are moving on to the evaluation and criting tools. In this, firstly we are discussing the build time tools. The example I am taking, that is from the take the example of simple spell checks to more sophisticated tools that will give us a matrix reporting number of displays, widgets, or even more advanced, they tell us the depth of menus, trees, redundancies, inconsistency or label. Then tool is display analysis program. Then today's there are so many graphical UIs being available to have a build time tools. Then we have the runtime logging software. They capture the user pattern of activity. Whatever user is doing, based on his or her activity, the pattern is being drawn and accordingly reports are being generated, and error frequencies, menu selections, dialog box experiences, they are being given. Then the different prototyping languages that can be used. First language that can be used is Java, means it is a kind of application or applet language, cross platform. The intent is that all the applications, they act on the same platforms. The hypercard, the movement between cards, that is screens, or we can use any kind of tool command language or scripting language. Then the various toolkits and languages. Toolkits, they provide the UI widgets that can be used to develop the application, and it focus on the developer, means to build the right application. Then it was all about the software tools that were being used as a building tool and evaluating and the criting tools. Thank you.